Hi guys, this is Acid Base 107 Part 4B, and what we're doing are the last two types of calculations for a weak base, strong acid titration, and we are here at 150 milliliters of HCl added, and we want to notice that this is the equivalence point. Okay, because our HCl's concentration is 0.02 and our methylamines concentration is 0.02 also. So when they have equal amount of milliliters, that means that they're at the equivalence point. The same amount of acid has been added as there was base to start with. Okay, so when you get to an equivalence point problem, I'm going to use this pen, you're going to have two parts to it. You're going to have a neutralization reaction, and that's going to contain a BCA calculation. And then you'll have the equilibrium aspect of it, and that will have an ice table. Okay, so you're going to calculate the neutralization process first, and then you're going to use the information from here to do the equilibrium, because the equilibrium is what determines the pH. Okay. So with the neutralization, we know that we have CH3 and H2, and we're reacting it with acid to make CH3 and H3 plus H2O. And to find the moles of each of these, we're going to do molarity times liters. So 0.02 times 0.150. Okay, and this is going to be 0.003 moles for each of these, because they're both 150 milliliters times a 0.02 molar. And this guy's going to start at 0. We're going to lose 0.003 on both of these guys, and we'll gain 0.003 here. Water, we don't care about you. So we're going to go to 0 here, 0 here. And we'll have 0.003 moles of the protonated acid, or excuse me, the protonated base at the end of the neutralization reaction. No. Okay, so the equilibrium that's going to affect the pH is going to be the equilibrium of this interacting with water. And so we're going to need to find the concentration. And so this is going to be 0.003 divided by the 300 milliliters. And so we get our concentration of CH3 and H3 plus is equal to 0.01 molar. Okay, so the equilibrium reaction that's going to affect the pH is the protonated base, CH3 and H3 plus H2O. And since this is a protonated base, it's going to act as a base, or excuse me, it's going to act as an acid. So one of these hydrogens is going to transfer to the water. It's going to produce H3O plus and CH3 and H2. Okay. Now, we know the initial concentration of this is the 0.01, so that's going to go up here. And we don't care about water. And these guys are both going to start at 0. And we're going to lose X, gain X, gain X. So we get 0.01 minus X, X, and X. Now, what we want to remember is that this is a protonated base. So CH3 NH3 plus is acting as an acid. Therefore, we need a Ka. And we know that Ka times KB equals KW. And our Ka is our unknown. Our Kb for methylamine is 4.4 times 10 to the minus 4 is equal to 1 times 10 to the minus 14. So, do a little bit of baby algebra here. And 4. And we're going to get Ka equals 2.3 times 10 to the minus 11. And that's going to govern this equilibrium. And so our job, seeing that this is small, we're going to be able to estimate X out of here. And so the expression that we're going to have, to find the H3O plus, which is ultimately going to lead us to the pH, is going to be X squared, these two guys, over 0.01 is equal to the Ka, 2.3 times 10 to the minus 11. So 2.3 second E negative 11 times 0.01, and then we'll square root that. Okay, and we get X equal to 4.8 times 10 to the minus 7, and that's equal to the concentration of the hydronium ion. So if we negative log that, we're going to get our pH, and that's equal to 6.3. Okay, and that makes sense with our graph. We started up here, pH is basic, and we dropped here a little bit before the equivalence point, and then at the equivalence point, we would expect it to be slightly less than neutral, because what we have in solution is an acid, a conjugate acid of a weak base. So our pH at the equivalence point is expected to be less than 7. All right, moving on with 160 milliliters of HCl added. So I'm going to drop down here a little bit. We are going to have a neutralization, and then no equilibrium. All we're going to do is negative log our concentration to get to a POH. Okay, so our neutralization reaction is going to be the same as what we have up here. We have CH3 and H2 plus our hydronium ion makes CH3 and H3 plus water. And we're going to have a BCA table here. We know that this is 0.003 moles. This is our initial. And then the hydronium concentration, the hydronium moles is going to come by doing molarity times liters is equal to moles. The molarity is 0.020, right? Did I get that right? Yeah. And then the liters is 160 milliliters, or 0.160 liters. So 0.02 times 0.160. Okay, and we get 0.0032. We don't care about water. This guy's starting at 0. And then we're going to lose the smaller of the two. And that's going to give us 0 here and 0.0002 moles of H3O plus left over. And in order to find the concentration, we are going to divide by the total number of milliliters, or total number of liters. And we started with 150 of this guy, and we've added 160 of this guy. So this is going to be 310, right? Well, let me just check my math there. 160, yes, plus 150, 310. So 310 milliliters is 0.310 liters. So 0.0002 divided by 0.310. And so we get the concentration of the H3O plus is equal to 6.5 times 10 to the minus 4. And I forgot to say that we are going to add 0.003 of this, which gives us 0.003 there. Okay, and the point is that the pH is going to be more affected by this hydronium, this strong acid, than any equilibrium that the CH3, NH3 will produce. So if we know the concentration of the hydronium, we can put this up here. And sorry, I should have said pH here. So if we negative log 6.5 times 10 to the minus 4, that's going to be equal to our pH. So negative log second answer, close brackets, and we get pH equal to 3.2. Okay, and that makes sense. We've added 10 more milliliters of acid, so we would expect it to drop in pH. So pH went from 6.3 to 3.2, so that makes sense. Now if I change this to 170 milliliters, then we'd see another drop in the pH, but I won't do that. So I think we've had enough of this. Thank you for your attention, and I'm sorry that these notes were so very, very long. And good luck with the acid base 6 worksheet. Please email me if you have any questions. I miss seeing you guys, and we'll talk soon. Okay, bye.